have our 4 experts. And I think we've got a good spread. We have a machine manufacturer, we have a user of machines to provide a service, and we have 2 independent analysts.
I was intrigued by your mention of 3D Systems suing you. You never mentioned what happened afterwards, but I'm fascinated by the conflict between the patent guys and the open source movement. And I think that's a fundamental question that we need to address.
We announced the resolution actually a few weeks ago. We settled the lawsuit with 3D Systems. I mean, I believe in a patent system for encouraging technology development. I think you need protection to encourage investment in R&D. It's that simple. But I think the current patent system is actually very poorly aligned for basically giving protection to people who actually invested a lot. And so I think we need a lot of reform to make it more effective, basically, on things like software patents and stuff like that.
Yeah, I think it's a good point. You know, I started Shapeways 8 years ago, so I've been around in this market for a bit, but I think the patents are holding up some innovation. And I do agree with you that it would be amazing if the patent holders in 3D printing space, I would support it, would put all their patents in an organization, and then everybody could license it, and then the patent holders would be compensated for, you know, anyone who would be using their patents. I would be open to that, because then you get innovation, and then at the same time you protect the rights of people who put in all the money and the time and the smarts to develop that technology. They get the reward for it, the money, and at the same time everybody can use it, which is to the benefit of everybody. I think that's what patents were intended to be, and that we can solve in that way. But I'm not too sure whether everybody agrees with me. So,
Terry, as somebody who's been in the industry a long time and knows all the major players, how likely do you think it is that they would be even willing to entertain the possibility of potentially doing that?
Yeah, there's no chance it's not going to happen, because the legal community won't allow it. And as much as we, well, lawyers have a lot of influence in these companies, and the executives will listen to them and follow their instruction, and to the point where it'll create the gridlock that won't allow that to happen. It just won't happen.
I guess one consideration is you were kind of the first publicly outed Kickstarter that was sued. There are other smaller players in the market who are also being sued by other vendors, and now we're seeing the end of early patents, of other early patents. So laser sintering is now gone, 3D printing is about to go. You know, there's lots and lots of other IP, and there's now lots of companies emerging doing low-end laser sintering technologies, doing low-end lithography technologies. So could just be the start of things all over again, I don't know. But, or whether the big boys will leave you alone. You know, is it bad press to go after the little guy? You know, we live in a very different world order now, but you felt the sharp end.
Yeah, I mean, we definitely thought that the PR component would work in our favor, but honestly, I think Terry's right that a lot of these things are driven by lawyers who have a very different viewpoint than the business people involved.
We have heard a lot about the machine technology and machine developments, software developments, but there was little speech about materials. Dr. Reeves mentioned actually that the current materials are not designed for 3D printing. Wouldn't 3D printing community require more investment or more innovation in the materials part, actually?
We develop all the materials that go in the Form 1, and that is a huge part of what we do, and it's also a growing part. Obviously, we have to build first the machine to actually use these things, but now we're expanding the capabilities a lot on the material side, and I think even if people aren't talking about it, it's a huge portion of R&D in 3D printing.
Yeah, I mean, I don't know about fashion necessarily being different to any other industry. You know, material is key to driving certainly adoption of the tech for making products. And what I alluded to earlier, there's some great work, guys at Nottingham University in the UK doing something called reactive jetting, which is not taking existing polymers, but taking chemical constituents of polymers, jetting them, and then letting them polymerize. Now, you can only do that additively out of a print head. So, you know, my vision, hopefully, is that's where we'll go to in the future. The machines will make the materials. They won't take material and convert it from a monomer into a polymer. They'll take constituent parts of polymers, let them react. So, you know, maybe that will give you the flexible materials or the tactile materials that you guys as an industry need within fashion, or equally, it will give us the material properties we need in aerospace or medical or biotech. I think that's kind of the more long-term vision for how we'll genuinely get the materials we want, rather than taking existing polymers and just trying to put them into a form that we can use.
Yeah, I have a comment about materials. I think Jeff Kowalski of Autodesk, he's a chief technology officer at the company. He said it best. He said, by putting a smart chip on your material cartridge is putting your business ahead of your customers. And I couldn't agree more. And I think that business model is going to go away. And there are some very big companies that previously were not interested in 3D printing because the business is so small. You know, $3-4 billion industry. That's tiny to some of these giant chemical companies. But now, I can't say most, but many are looking at this, and some have teams of as many as 20 to 30 people working on it in a covert way. I mean, they haven't disclosed their involvement, but they've been working on it for years. Seeing the growth trends and getting ready, watching the patents expire, understanding that manufacturing is a big business compared to prototyping. So we think that we're going to see many new types of materials being developed for these processes over the foreseeable future that we haven't seen in the past. So that's good news. That's good for customers. We need to have more choices. We need to have better competitive pricing, and so that's in the works.
That's a good question around the materials. I think the interesting bit about 3D printing is that it both needs and software to design, but also to run the machines. You need the hardware, which is electrical and mechanical engineering work, and then you need materials science, which then builds the materials that give you new capabilities. I think we've learned how to develop software rather quickly. We are reasonably good as humans to build mechanical and electrical devices, but material science is still a rather slow process. And if you take on top of that after you develop a new material, those materials typically are made in big chemical plants, building those plants and making sure that they are actually economically viable, to Terry's point, requires a lot of investment. And that only comes when the industry or the opportunity is big enough. Now that's starting to change. People start to see the opportunity. So that's happening. What I also like to add is two things. One, the reactive technology is, I think, another way to look at materials, just like digital materials, which a lot of people probably don't know about. But what you can do by making microstructures, you can start mimicking the properties of one material using another material. And certain types of 3D printing are very well suited to do that. So you can mimic the feel of textile, the feel of rubber, or other materials using another material. And that is kind of interesting, especially when the structure sizes become smaller and smaller and smaller. You don't see anymore that underneath are very small structures that are mimicking the behavior of a material that you're familiar with. So there are three ways to do it, right? Pure, hard material science, the reactive way to do it, and then mimicking materials using microstructures. And I think all three of them have a merit, and they are starting to accelerate as the market is growing.
I wanted to come back to the issue of intellectual property, and we talked about it earlier this morning. From the flip side, meaning how are manufacturing companies going to protect their IP in a world where customers can make things away from control? And Phil, you touched on this briefly in terms of this idea of streaming IP. Can you expand on that? And perhaps I'd like to get input from the rest of the panel about what you see in the future, 5-10 years from now. How is IP going to be affected from a manufacturer's perspective? How do they protect the products they're currently making in physical form and transform their business models into a digital one? I
could just say, read the book that the Intellectual Property Office are going to publish in the end of January this year. So we've just written a whole book with a whole series of lawyers about the IP implications, not just we talked about patents, but patents is one form of intellectual property. You've got copyright, you've got design rights. There are multiple forms of copyright, whether it's around software or tangible hardware. How do you protect it in the world of 3D printing? I would argue 3D printing is no different to any other way of making. If I want to make a true copy of something, the easiest way is to make a silicon rubber mold and pour something into it, or to machine a copy of what you have. So 3D printing doesn't change anything in that respect. The biggest fear from the manufacturers that we work with isn't about IP infringement, it's about passing off, and then when the liability of failure lies. So if I copy an Airbus part and that part is sold as an Airbus part, and it fails as an Airbus part, and the liability lies with Airbus, but it isn't an Airbus part, that's the issue about copyright protection or design right protection down the line. So I think we're to some degree over-worrying the copyright issue or the trademark issue. The other thing you have to be conscious of is certain industries are very, very different in the way that they protect their component parts. So if you take automotive, one of the case studies we looked at with the IPO was the automotive industry. In Europe, we have something called the block exemption, which says any part on a motor vehicle in Europe that is a part that will, or is known to wear or fail, can be manufactured by any third party, not under license, just by any third party, to the designs of the original company. And the original company has to make those designs available. So if you design a car with very specific brake shoes, you have to make those brake shoe drawings available to everybody else to make piece parts, because otherwise you're actually stifling a competitive marketplace. So different markets have different controls over the aftermarket. So it's a very complex issue, but I'm not sure 3D printing changes the paradigm from machining or molding or casting. It's no different to the existing manufacturing infrastructure that we have. The biggest worry is when you modify shapes, because in the music industry we have a very predefined way of saying what is or isn't copyright infringement. It's a certain set of a certain number of notes and a certain beat and a certain rhythm that's quantifiable, and you can sue somebody for copyright infringement. With objects, as yet, we haven't defined that. And you can look at an STL file and say that STL file is the same as that STL file. But actually, I can modify thousands of facets in it and try and use that as proof that it is different. And as yet, legislation hasn't caught up with how geometry changes fundamentally impact on IP. So that's, I mean, you guys have this all the time. We've looked at your website. You have pretty solid and firm rules about what is or isn't IP infringement. But whether you can police them or not in an automated way is a really difficult thing to get your head around.
Yeah, I agree with you, Phil, but I disagree a little bit. I think that in the past, if a company decides to copy, say, Mickey Mouse, a Disney character, right, figurine, and produces a mold and sells tens or hundreds of thousands of these, Disney will find that company and it will shut them down, guaranteed. Or at least they'll try, and they probably will. Now, think about today or tomorrow, where now you break that up, and that's not one company doing hundreds of thousands of parts, but maybe it's 1,000 companies doing hundreds of parts. And these are little companies, or maybe not even companies, but individuals, because somebody scanned Mickey Mouse, put it on the web, and they download it, now they're just putting them out there. How does Disney go after those 1,000 companies? So I think it does introduce some interesting IP implications that we haven't seen in the past. Now, you know, will that happen? Possibly, probably. Yeah.
Just as an aside, the one thing that came out of the report we did for the UK government is not to legislate and predicate against 3D printers. It's actually to look at the infrastructure around consumer 3D scanning, because that's actually where the root of the infringement comes from, which is your point here. You know, let's walk up and down the strip outside. I'm sure there are lots and lots of knockoff T-shirt shops selling T-shirts with intellectual properties that are owned by all of these casinos, whether it's the Mirage or the Venetian or whoever. Yeah, nobody is going out there closing down the companies that make the 2D T-shirt printing machines. Yeah, actually, if you trace it back, the people who are in the wrong are the ones who took the IP, and in that case, the IP is a trademark, and then made that trademark available for copying. So, yeah, predicating against 3D printing machines, actually, it's got to be the source of the infringement, and the source is actually the digital thing, not the tangible.
Just out of interest, for the work that you've done, which I obviously haven't seen yet, was the fidelity of 3D printing systems an issue, i.e., you can replicate something, but it's going to have build lines on it, and etc.?
Yes, and there's some interesting precedent in the rendering sector about Fidelity. So there's a law case between a rendering company and Toyota, where the rendering company were asked to render a vehicle that wasn't even ready yet to do photorealistic rendering, and the rendering was so good it looked like the original vehicle. But the rendering company were not told that Toyota were then going to use that in advertising and were successfully sued, i.e. Toyota was successfully sued, because that wasn't what they said they would do with the rendered objects. So, this is already happening in the rendering CAD space about what is real and what is not real. Now, in 3D printing, if you scan something and then claim that it's not an infringement because it's not accurate enough, is that good enough? And I think that's your question. And at the moment, it's about passing off. It's about what do you commercially want to do with the object that you made. If it's Mickey Mouse and it looks like Mickey Mouse and you say it's Mickey Mouse and in a court of law everyone says it's Mickey Mouse, you're passing off Mickey Mouse. Just because it's a bad stepped Mickey Mouse with a poor STL file, if you're selling it as Mickey Mouse, it's still Mickey Mouse. And that's the issue about what you're selling, because if you go onto Peter's website, which we have, and type Mickey Mouse, you'll probably find 160 different hits on Mickey Mouse or Disney. In some cases, you'll find a Disney logo that you can download and 3D print. In other cases, you actually find what isn't the Disney logo. It's somebody's interpretation of the Disney logo with the castle, and then they've put Disneyland, and Disneyland actually isn't a trademark, but they've used the... So, yeah, what is faithful and isn't faithful is very much open to question.
You guys touched on the lock-in versus open material model, and right now there's a lot of discussion in the FDM world, right? Because there's kind of that fight going on, and I think it's probably likely the open model will prevail. I'm curious what your thoughts are for SLA as more desktop SLA printers come into market. Do you what are your thoughts on that? And do you support a open model for the SLA printers?
Right now, it's kind of an irrelevant question for us because the materials we make are so much better fit for our machines that they're the only ones that most people would like to use. But that probably will change over time. And of course, there's a business component where people are making higher margins off the materials, and I think nobody wants to see it go towards the extreme end that the 2D printer world has gone, where ink sells for tens of thousands of dollars a gallon or something like that. But I think we will see, at least on the desktop side, that manufacturers will continue to try to work primarily with their own materials, just because there's much more than the cost of material for a desktop machine, because of the usability, what a cartridge provides, and being able to sort of guarantee the end-to-end system is much more important. I think it's on the higher end that it's going to be much more important to open up the systems to get lower costs for manufacturing type applications.
There was a lot of talk in the different some of the different topics today on people buying printers in their home versus the service model, and I know we saw Shapeways and 3D hubs with these online models. I'm curious because it's kind of interesting to me that we don't see these 3D printing stores where somebody might just come in and have access to a multitude of different types of printers. And I'm just curious what the panel's thoughts are on why we don't see that model, and do you think there are any particular challenges or advantages to that versus online model?
So I think why we don't have it is because we use high-end machines that require a type of a manufacturing setup. You need high voltage, you need compressed air, and to boot, typical build times are many hours, even for a small part. Now, we get around very slow throughput by putting many parts in one machine, which only works really well if you have many orders or many people coming in and giving you that. Now, the web is perfect for that, because you can build in one machine something for someone in Iowa and someone from San Francisco, someone from New York. You build it in the same machine and then you ship it out. As demand increases, that geographic demand will increase, and you can do it in a city, for instance. But still, you have longer build times with current technology. Now, technology will get better and better. It will get faster. HP announced a machine that's 10 times faster, so that will help. But current technology, even with desktop printers, you need to wait quite a bit of time if you have a sizable type object. And people's experience with shop in a retail store is you walk in, you see something, you buy it, and you take it with you. You could do something like what is happening with the photo industry, perhaps, where you bring in your stuff and then a few hours later you can pick it up in a mold type environment. Could be, but that's very limiting for what kind of technology you can offer. Basically only works for plastics, and actually, very exciting things like metals and ceramics and other materials are not very possible like that. So there are basically supply chain and technology problems that we have to overcome before that becomes a reality that fits the consumer needs.
Can I ask a question to help answer this to you?
Sure.
Okay, so I want to ask a question. So what's a typical build time on one of your laser sintering machines? A typical, and then that's one, and then what's the cool down time?
Yeah.
And then the breakout. So if you add that all up.
So the typical machines, and it's a kind of fun question that you're asking for the SLS machines that we use the most. Actually, first and foremost, they're designed to be slow. So instead of being wide and not so high, they're built to be very narrow and very high in tray size. There's a technical reason for it, but since the time it takes to print is defined by the height, you have to wait a long time before it's ready. It's building about ½ inch an hour. And then it needs to cool the same amount of time that you're building. Now, what we do is we try to run the minimal height trays that we can get away with on the maximum size machines that we can get. So you have a big surface area and you don't have a lot of height, so you optimize for speed. We are currently running 2 builds a day on certain machines. So we have a 24-hour from the moment we start printing to the moment we could ship. But then, of course, your process has to be incredibly tight, which we haven't achieved for everybody yet. We do have a 2-day rush, which is getting close to it. But still, we're talking about days here. So when the machines get 10 times faster, the same could be done not in 12 hours, but in 2 hours. And then your cooldown time is probably 2 hours, or there is no cooldown time. And all of a sudden, the whole dynamic starts to change. So again, to my point, the current technology doesn't support, in most cases, the consumer needs. And this is only talking about plastic, where we get a 10 times faster machine. For metals and other materials, the technology is maybe built, and I'm not aware of it, but it's definitely not commercially available in the near future.
What areas do you see a reduction in price coming in the future to the end consumer?
So the current cost of 3D printing is defined by a little bit of utility, but that's almost irrelevant. Then you have machine, material, and labor cost. If you have a home printer, labor cost is your own time, but you still have a machine that you depreciate and you have material that you're running, right? If the machine gets a lot faster, then you can build many more parts with the same machine, so your machine cost comes down. And then material cost depends on what people charge for the material and how much you can reuse, because in certain technologies you can reuse a part or all of the material that is wasted in the process. In other technologies you either don't waste or you throw away that excess material. And that defines the material cost. I do think, since printing is a three-dimensional thing, the big parts are almost by necessity today very expensive, unfortunately. An iPhone case is reasonably easy at a reasonable price to make. An iPad case is already way more expensive, and if you go to the size of a small chair, you're starting to hit big numbers. And therefore prices need to come down by orders of magnitude, so 10 to 100 times. And that is basically way faster machines and materials that are made at very, very much higher quantities than they're made today. All of that is a little bit of a chicken and egg, because when we get everybody start to believe in the market and we build many more machines, much faster machines, we start to produce much more material, then all those costs start to come down. And then it's up to us to make sure that the labor component is also, by optimizing our processes, isn't starting to become a problem. But I don't think that will be an issue. We can get around that. So I think in the years to come, just like we've seen with computing, a base home computer is still roughly the same price, but if you see what you get for that price, it's enormously much more powerful than even 5 years ago. And the same will happen with 3D printing. I'm sure of it.
I wondered what you guys think in terms of an analogy to help to think about the way that people are going to, on a prosumer level, use 3D printing, similar to the way that digital SLRs exist within, every single person in this room has a camera, but digital SLRs are a separate segment of the consumer segment that still appeal to the people who, came alive, like the children who are using 3D printing, to people who may be looking to do it as a profession or to make a living out of it. So I wondered sort of, that's kind of my first question. My second would be just in terms of where you see investment dollars going in the future from a venture or from research perspective in the larger sense, and they're completely unrelated questions, but hoping to get some thoughts around it.
I think there's a ton of analogies with digital SLRs and a few other products that have this kind of prosumer segment, at least to what our product does. I mean, we traditionally, people try to split the market very much into consumer versus professional, but really the technology is the technology and the capability is the capability, and sometimes that maps onto one or the other very clearly, but it doesn't have to. And so yeah, digital SLRs are a great example where it could be used for work, and it could be used for fun, and that's sort of a similar place where we occupy. And even if, in our case, almost all of our customers are professional users, there's still the prosumer component is still there, where they buy it in a consumer fashion, and they don't worry about TCO and ROI and process to buy this thing. It's the end designer and engineer who says, I want this thing, I'm going to get it, and I'm going to use it, and I don't have to think too much about what's going on here. So that's sort of what prosumer means for us.
Yeah, I mean, the prosumer thing is interesting, isn't it? If you look at the history of prosumer, it was about taking professional technologies to the consumer level. The very early, not way before SLR, I think right back to video cameras, JVC, 1976, taking what was a $1 million camera from a TV studio and putting it into the hands of somebody to do a wedding. That was prosumer. That's what it meant, taking professional to consumer. Somehow the marketing people in 3D companies have flipped this around and actually said, no, what we have now is consumer, but maybe we're not selling as many as we want to. So we make it prosumer, okay? And we take the consumer stuff up and convince the professionals they need it when they had it all along, but it was too expensive for them, and now they can have what was consumer, but it's a bit more expensive. So it's a little bit mixed up as a set of terminology.
I take offense to that, Phil. What consumer stereolithography printers did you see before the Form 1? The only other stereolithography... Yeah. The machines were hundreds of thousands of dollar machines. So, I mean, we're definitely bringing professional stuff down to consumer level, or at least to be able to use it like you use a consumer product.
So I'd like to comment on that, because I think this is classical what we're seeing here, and I talked a little bit about it earlier. If you heard my talk, is that we're thinking in old economy terms about something that is radically transforming our society and economy. You have consumers and you have industry, or you have professionals and you have consumers. And I think that is completely going to go away. You have all kinds of shades of gray. You have people who use it all the time and are very good at it, and you have people who use it every once in a while and are either not too good at it, or they might be even very good at it. And the technology might fit your needs if it's very coarse and rough because it's utilitarian, or it needs to be super high grade because it's a wedding ring. And the wedding ring could be typically once in a lifetime, and some other things you use much more often. So I think 3D printing and the way it democratizes the access to manufacturing is going to take away all those barriers. You need professionals were there because they were working for big companies that were manufacturing products, and that's how we think about it. But that's going to go away. People can make their own products. Some might not do it, some might, and who cares? And whether your machine is used by someone at home for hobby projects, or whether it's used by a high-end invention company, as long as they're happy with it. And the same holds true for our machines. We have machines that cost almost $1 million, and in some cases we print little plastic rings for kids on it, and other times we print things that are used to detect small particles that are coming from outer space by scientists. It doesn't matter. And it's just like, it's an old type of thinking, and therefore I struggle also with the camera analogy. I was really thinking hard to give you a really good answer on that, but I think it's completely changing the landscape of how people think about manufacturing, and that's the interesting bit, and that's why it's so unpredictable what's going to happen in the next couple of years, but it's going to be a lot of fun.
Okay, and I think the second part of the question was, where are the investment dollars going to be going? Terry, is this something that you monitor closely?
Well, do we monitor? We're project-driven, customer-driven, and so investment dollars are going in a lot of places. Some places we're quite frankly surprised at. It's like, wow, why would you do that? But hey, you know, in other places it makes sense. And the point I made earlier is just a whole lot of money now, at least an order of magnitude more today than just a few years ago, going into development, not only technology development, but also application development. And that's maybe the really a big opportunity is to take what we have today and to modify it for specific applications, just like the hearing aid people have done, jewelry, orthopedic implants, and the list goes on and on. And so that's, I think there's a lot of room for growth in that area. It's taking what we already have, maybe some new IP, and probably some new IP to make it special and to protect what you've developed. But yeah, there's just so many possibilities, from textile designs, fashion design, to furniture, to lighting design, to the list goes on and on and on. And we have a lot of the tools we've had. We can now benefit from more than 25 years of development and now begin to apply these tools and methods to these different vertical areas.
Just to comment, I wasn't rudely looking at my phone then because Terry was speaking. I was looking at my phone to check the stock market valuation of Align Technologies relative to Stratasys and 3D Systems, and it's higher. Now, Align, if you're not familiar with Align, are the guys who do the dental aligners, the Invisalign aligners, where they're vacuum forming over 3D printed master patterns. That is their business. That's all their business is. And their business is now worth more in terms of market cap than any of the 3D vendors. So, if you look at it in the classical supply chain sense, the people at the top make the most money. Yeah, the guys at the bottom don't. Yes, the materials is a nice industry to be in, but I'd much rather be at that end of the supply chain than that end. And from an investment perspective, maybe when we're focusing too much on the tech and the material and not on the things that we make from the tech and the material. And Align is probably a really good, indication of that.
That's a classic example of developing the technology for a specific application. They poured years and tens of millions of dollars into, capturing the data that's needed from the impressions with CT scans to, calculating, interpolating from crooked teeth to straight teeth, and all that. There's a video online. If you haven't seen it, it's remarkable. All the automation that Align has done that surrounds. So you have the 3D printers. Very key. The company wouldn't exist without those, but they have all of this automation that goes on. So there's no people. It's just very few people, and all of these processes that's going on in the background. And that's where it's at too. I mean, when you look at decentralized, I think the point that you made earlier, Phil, in your presentation is taking these printers and decentralizing manufacturing. That's not going to get it done because you have all these other processes, from material removing, the support removal, to surface finish, to inspection, to all these things that go on that need to surround these machines. It's not just printing a part out and, oh yeah, maybe if you're doing a Mickey Mouse, but if you're doing an aerospace part or a medical part, there's a lot of things that go on, particularly with metals.
If I can add. Yeah. So I think it's an interesting question to ask about the investments because, since this is such a new technology, I think a lot of investments need to be made in all kinds of ways to get it from where we are today to what we all believe it can be. And the interesting bit is, though, that the most profound investments that we all know of, especially over the last 20 years, they're all made in software, right? I mean, if you think about the most famous investment venture capitalists, they're mainly investing in software. And I already mentioned earlier that you have software, the mechanical electrical layer, and then the material science layer. Well, software is really quick. So if you invest in a company, like 3 years later, you could make a lot of money out of it. If you invest in a machine type company, already much, much slower. And as a result, I struggle today to come up with names of investors that are investing in that type of company, although you're one of them, and I think they're courageous that they did that, and it's great. Because if we don't invest in a machine layer, we get stuck. And then you have the material layer. Now you're doing some of it yourself, probably also out of necessity. But basically most research in materials is done by chemical companies or actually, by big companies out of need, and not because it's invested in, because that timeline is even longer. But if we want to accelerate this, the money needs to go in, and not only at the software layer. However, if you think about that, then you can make some predictions, right? We will see the biggest advances for 3D printing on the software layer, then in the hardware layer, and last, unfortunately, in the material science part of it. Let's see whether that pans out.
I guess Phil's point made me wonder a little bit about the idea of the applications being sort of more predominant in the face of the way that the markets favor them. Would you then say that it's almost like the apps sort of revolution going on in Silicon Valley right now, in that, and maybe Terry, you can comment on investment dollars. The reason why I'm focused on it mainly is because, I have an interest in the hardware manufacturing side, and sort of wondering if that's the best place to maybe roost.
It's hard to predict the future, where this is going. As much as some of us would like to think we know where it's going, and some of us have a feel for where it's going, but I do think applications, the killer apps. We haven't really, I don't know, is Invisalign a killer app? You could argue that it is, but we do think that there's certain sectors that will benefit as customers of these products. The products themselves, machines, material, software, yeah, there's a business there, but maybe the bigger business opportunity are the customers, the users of these products, and the dental companies, the jewelry companies, the fashion companies, the Miller, Herman Miller and Steelcase of the world. Perhaps, I'm not saying they will, but there's all these companies out there that really are, the light bulbs coming on, and they're looking, exploring at, Hallmark, and what's the other Hallmark competitor in the room now, or at least she was earlier, Kimberly Clark. And so the list goes on of these companies that the light bulb's coming on, they're looking at how do we not cash into this, but perhaps modifying some of our products by 5 or 10% to personalize them, and to be able to then charge a 20 to 30% premium on those. There's all kinds of examples like that, and now companies are just, for the most part, beginning to explore that opportunity. Do you agree?
Well, I can add perhaps a little bit, but I struggle with that one. I think you're right that besides where we just talked about, like how do we advance it, I think the content is key, right? What are we making with it? And to your point, Invisalign has a great business around it, and they solve a big need. Good. There are probably many, many more we can solve with 3D printing, and we'll figure them out. And lots of them have been discussed today already. Many more will be found. But I do agree, in the end, it's about the end user. There is a need. People want to have the product they have in their mind. And mass manufacturing doesn't always give it to them. And 3D printing sometimes is more efficient in that, because it has all kinds of benefits that we discussed. So I think you're right in that sense, that it is all about the end user. It's about you. It's about us. What do we want? And 3D printing will give us more power to get that. But how that completely will pan out, and how drastically it will transform our society and the way we will make things, whether different types of companies are needed versus the ones that we're used to, who knows? And where the value will be created is probably, I agree with that one, very close to the end user.
This morning, Carl Bass said that all the machines have problems with reliability, quality, resolution, speed, and material compatibility. And I wonder, maybe Max, but anyone who has insight, what are some of the fundamental technology breakthroughs that you see that will change that picture in the next 5 years?
I don't know that there's a single place to look for that stuff. It's going to continue to be a kind of simultaneous push across software, machines, and materials. I think one big area, though, that does cut across all those, that's going to become much more prevalent, is more basically closed loop type machines with more integrated sensing that are able to adjust the process as they run. For the most part, the machines, especially the production type machines like the SLS machines, the way they work now is they have a very small operating window, and you have to basically they're like very finely tuned devices that have to just hit the middle of that window, and occasionally they drift out, and then you have like a whole bed full of crappy parts. And you can keep battling that problem by making the things more precise and calibrating them better and whatever. But the way that most lower cost machines in general work is by adding more sensing and more intelligence to self-correct by themselves. So that's definitely a big area that's going to address a lot of those issues.
Yeah, I agree with that. You know, it's surprising how low-tech the 3D printers are actually. I mean, what they do is amazing, but they're pretty low-tech in the construction base. So, you know, and there's two ways to solve the problem of accuracy and reliability. One is over-engineering. You make it so good that it won't fail, even if you throw it around. Or you make it a closed-loop system where you continuously measure that. You say to a machine, do this, and then you measure, is it doing it? And if it isn't, you take preventive actions. So either you make a closed-loop system, which I think is the best solution, because then you can keep the design reasonably priced, or you over-engineer and then over-engineer some more. Basically, the high-end machines are prototypes still. You know, there is such a small market that the machines are built at such low volume that they're all handcrafted. You have to think about the cars in the early 20th century, 1930s. All hand-built, tuned by master mechanics, driven by people who know what they were doing, because driving a car of that era was extremely difficult. And look where we got. I hope it will take a little bit less time with 3D printers than it did with cars. But there is some similarity there. Using similarities seems to be popular, so I thought I chimed in. So. But I think the modern type car is much more closed loop. You know, measurement devices everywhere. And if something is wrong, at least you get a warning. And then you can stop, or you can, sometimes the car even autocorrects by changing the timing of the combustion, etc.
If I could just expand, I agree with Carl's comments if you accurately restated them. He and I have talked about this before. We're in agreement, and I agree with Pete. You know, these machines really were built for prototyping, and you don't have to have a lot of repeatability with prototyping or reliability, uptime. You can get away with machines that you're just building one-off parts. You know, maybe a few models and prototype parts that are very temporary, models of your design. So they don't have. But manufacturing is a whole nother animal. It's a whole nother level of quality requirement. So we believe that the market's going to require that quality. And whenever there's a market demand and opportunity, someone will fill that space. Someone, for example, let me give you an example. GE Aviation, with Morse Technologies acquisition, which happened a couple of years ago, they are using these prototyping machines to manufacture parts. Now, they would have liked to have gotten machines that are more reliable and repeatable and have these closed-loop process controls and so forth. They've had to develop that stuff on their own. They've had to shoulder the burden, pay for that on their own to make it work. They did make it work, but a tremendous investment on the part of GE's, on the corporation. Most companies won't bear that cost, but they want to benefit from that. So over time, we think that companies like, is it Mazak, DMG, Moriseki, Cincinnati, the machine tool companies, they know precision and quality because they've done that for decades. And so, as these two industries come together, we see that the quality, improving dramatically, just simply because there's an opportunity for the market, demands it.
I guess the biggest issue is you've got according to STM, 7 different types of additive technology, and now hundreds of vendors making different machines. These are fundamentally different types of manufacturing technology. So the idea that they should all be as controllable, as accurate, as repeatable as one another, fundamentally there's no reason why we couldn't make an inkjetting type technology as repeatable with a similar duty cycle to an HP wide format Indigo press at the same price. Because that's an infinitely more complex machine than anything in the additive world and sells for a similar price. Because that technology is repeatable, it is scalable. That's very different to a laser sintering machine, which is a thermal process with optics that heat up and cool down, and the system's constantly in this kind of hysteresis loop of trying to get itself back together. Or an Arcan machine with an electron beam that you're trying to use magnets to pull electrons around. They're very different technologies. Some of them will lend themselves to being scalable and being accurate and repeatable. And others, yeah, we can faff around in university labs for the next 10 decades trying to make them more accurate and more repeatable. But sometimes maybe we just have to put our hand up and say, no, this process isn't going any further. So, Carl's comments this morning were a little bit flippant. Nothing is good enough, materials are not good enough, processes are not good enough, but then didn't actually tell us why Spark was any different. So, I guess that's the issue. It's a very broad church of different technologies out there now. Some will improve, and I think some will just stay pretty much where they are.
What properties would enable new businesses or applications? So, for example, are you looking for stronger plastics, lighter metals? And the second question is the economics. Everybody's describing these materials as very, very expensive. So what are the barriers to bringing those prices down?
I think in the first instance, I'll take that one. I think it's a case of build it and they will come. If a material happens that suits a particular application, then somebody's going to do it. That's a given. And the choices in materials at the moment are okay, but there's so much scope for new materials. And Phil touched on before, not even putting the materials, but the constituent parts of material into a printer and the printer printing the material as it prints the part. It's entirely open-ended. I think we're nowhere near any sort of saturation point where people are pushing on doors at the moment. We're in the room, we don't know where to go. Sorry, what was the second part of the question? Then we want to pick up on.
So it had to do with material pricing, the second part?
That's right. What are the barriers to bringing down that pricing?
Yeah, so somebody mentioned volume. I think that certainly is a big part of this. The volumes have been relatively low, so in any industry, when volumes are low, prices are high. And so that's a factor. It has been kind of a chicken-egg thing because I know of companies who wanted to manufacture with this technology. The material quality is good enough, the manufacturing process is good enough, the surface finish, the accuracy, everything lines up except there's one showstopper, and that is price on material. Because when you get to the volume that they want to do with the parts, it becomes so expensive, so they revert back to the old way of doing it. The other is whatever the market will bear. And up to this point, the market has been willing to, it's kind of like buying an inkjet cartridge. You don't want to spend $40 on one, but you do. And the same is true here. It's like, yeah, I don't want to pay for it, but yeah, for prototyping quantities, it's so valuable to us to ensure that our design is correct or as close as we can get to being the best design possible. We will pay for that. We will pay for the machine, materials, services, whatever. But manufacturing is a whole nother animal, and that's another subject. But yeah, the market to this point has been willing to pay those high prices, but in the future, I don't think they will.
Answer to your first question, I think there's a lot, as Terry said, there's a lot of scope for new materials. Bear in mind the materials we have today, certainly on the polymer side of things, less so on metal, the polymers that we have available to us are a function of the machines that they're processed on. So FDM machines process long-chain amorphous polymers. They're not very good with semi-crystalline ones. Laser sintering machines are great with semi-crystalline materials, where there's a rapid phase change from solid, liquid, solid. Yeah? Max's process is absolutely brilliant with monomers that want to cross-link into polymers, but that's a function of the process. So when you map it out, what you find is there's gaping holes of polymers that we don't currently process. The world's largest used polymer by volume is PET. It's bottles. It's then bottle tops. I think we did some analysis and worked out that something like 12% by volume of all the world's polymers, by consumption of polymer, we actually have an equivalent material for at the moment in additive. The other 88% we don't. We're not touching any of those packaging materials, and that's where volume polymers are being used. So from an opportunity space, from a polymer company perspective, look at where the gaps are, and then work backwards and say, well, how can we process that material? Is there a platform that would let you do it? I think that's the issue. At the moment, we're still, as I said earlier this morning, we're shoehorning production applications into available materials, not using the materials we want to make the products that we want.
Add a last note, though. All right, I want to add a last note because over the last couple of questions, I think we touched a lot on the problems that we're facing in 3D printing. And although, we're at the early stages, everybody will agree on that. I also think that, we should also not forget that it's quite amazing what we can already do today. There is a wide variety of materials. People, there are already millions of people using additive, and millions of products are made, some of them extremely relevant. So I think that, there is a lot of development that we need. And it would be great if all these problems would be solved, because then many, many more people would use it. But, I would like to end it a bit on a positive note that there's already a lot possible, and that a lot of things can be made with 3D printing for reasonable prices at high quality, etc. So, get active now, because the more people use it, the faster development will go.
Okay, excellent. Thank you, Pete. Thank you to the rest of the panel. Thank you to you all for attending and for your questions. Thank you very much, and enjoy the rest of the show.